Hello everyone, I myself Rafia Ishrat from SRIT CSM first year. Today I am going to present a topic on potentiometric titrations from chemistry. Introduction. It is an analytic technique used to determine the concentration of unknown solutions. It is measured by electrode potential during the titrations. It is highly accurate and precise method. According to the definition of potentiometric titration, it is the titration method where the electrode potential of a solution is measured continuously as the titrant is added, and the endpoint is determined when the sudden changes takes place in potential. In this titration, we measure the endpoint of the titration by using the potentiometer. The principle of potentiometric titrations. Based on the measuring of electrical potential of a solution as the titrant is added, the potential changes can be observed at the endpoint. When you add the titrants, the changes in potential difference takes place, but at the certain value of the volume of the titrant, the potential difference increases with a high difference, and the potential difference can be measured by using two electrodes as indicator electrode and reference electrode. The difference in potential is recorded by using potentiometer or pH meter. The indicator electrode responds to the changes in analytic concentration, and the reference electrode provides constant potential. Near the endpoint, the potential changes takes place sharply. The potential versus volume graph helps us to identify the endpoint. Now see what electrodes are used in the potentiometric titrations. Indicator electrodes, glass electrode, metal electrode like platinum, gold and silver, ion selective electrodes are used. Reference electrodes, calomel electrode or silver chloride electrode. The apparatus used in the potentiometric titrations are indicator and reference electrodes, pH meter or potentiometer, burette, magnetic stirrer, beakers and titrant solutions. Coming to the procedure of potentiometric titrations, we have to prepare the analytic solution and we have to insert indicator and reference electrode, and next we have to add the titrants in small increments. While adding the small increments, we have to record the electrode potential after each addition. Again, we have to plot the potential versus volume graph. From the graph, we can determine the endpoint or equivalence point. Coming to the types of potentiometric titrations, there are 4 types of potentiometric titrations as acid-base titrations, redox titrations, precipitation titrations, and complexometric titrations. So the potentiometric curve. The potentiometric curve shows the potential change with titrant volume. A sharp jump indicates the endpoint. At a certain point in the graph, the potential difference increases with a high number. First and second derivative graph improves accuracy. Coming to the advantages of potentiometric titrations, it does not need any color indicators. It works with colored or murky samples. It is highly accurate and suitable for only automatic titrators, and it is highly reproducibility. And the disadvantages of potentiometric titrations: requires electrodes and instruments which are very cost, and needs calibration of pH meter and electrode. It is slower than simple visual titrations. The applications of potentiometric titrations: used to determine the potential difference and endpoints of acids and bases, analyze the water hardness, and used in environmental and industrial chemistry, and used to analyze the pharmaceutical products. The Conclusion of potentiometric titrations. Potentiometric titration is a valuable analytic tool used to find the endpoint, and due to its accuracy, precision, and suitability for a wide range of samples, we can find the titrations of colored and complex mixtures. Thank you.